So problem solving tip number one, which is just so useful in a way that, again, is kind of deceptively simple. Make sure you're always using the defining features of whatever your setup is. I swear, a good 70% of the problem sets that I did as an undergraduate math major essentially came down to looking at what was given, asking very critically, what is the definition of each term involved here, unraveling those definitions, and then just seeing how they piece together. So use whatever's the defining feature. And that's something that, again, maybe it shouldn't even be described as a tip, but I've put it down as number two, that when you give things meaningful names, that actually helps you move forward in your problem. And what we just did, in effect, is leverage a little bit of symmetry. In this case, it was innocuous, but quite often looking for symmetry in much harder setups, it's super generalizable, and it definitely will help you move forward. If you recognize that there's something symmetric, use that symmetry in some way. You can find one object that you can describe in two different ways. So we're going to look for one object that we have two different descriptions of. And this often can give you nice equations. In this context, it might mean relating the left and right hand side. So principle number 5 here is where we're going to come in. Again, it seems simple. It's something that you can nod along and be like, yeah, drawing pictures. It helps to think through what I'm looking at. But really, when you find yourself struggling with some setup that's not already visual or pictorial, it doesn't have to be making it geometric, but just having some kind of sketch to give meaning to your terms can be very helpful. And as a more specific problem-solving tip, when you have some numbers, multiple different numbers, see if you can make them coordinates in some space. Number 6 is to ask a simpler variant of the problem. You're solving something, it's hard. It's too hard. See if you can make it simpler in a way that you actually can solve and get some kind of foothold. Maybe that means loosening the constraints of the problem in some setups, or maybe it means looking at a sub-problem. What might seem like kind of a facetious tip, but I actually think it's maybe the most potent one and the most honest one. The way that you can get to this sort of point, just read a lot. Read as much as you can. Watch YouTube videos on math if they're substantive, things like that, and think a lot about problems, which is maybe frustrating because what you want is to be able to say like, well, how could I have come to this on my own without having merely recognized it? But I think the truth of the matter is a lot of what looks like insight and ingenuity is really just pattern recognition, but wearing a little bit of added clothing. Always, principle number 8 here, always gut check your answer. Okay, because there's going to be some little mistake that happens all the time. The great problem solvers aren't the ones who just never make little mistakes. They're the ones who have some way of recognizing what those mistakes are. And I think recognizing the truth of this as being the key to a lot of problem solving is actually pretty inspiring. Because oftentimes you find yourself in a situation where they're just faster, they're just better, they just recognize things more so than you do. And that can be a little bit intimidating, right? To look at one problem, think of yourself as like pretty savvy with math and knowing what's going on, and then just having someone burn through it with a wonderful bit of cleverness, this super beautiful argument that leaves you sitting there in the dust wondering like, wow, I'm just not in the same league at all, right? And you sometimes even think, well, he just has a math gene, right? That person, they just have some sort of innate instinct that makes them really good at this stuff. But I think the truth of the matter is that the people who are showing that kind of ingenuity, they've just exposed themselves to a huge number of patterns, and you too could get there, right? There is a path towards that, which takes the form of practice. But not just practice. Practice where you're taking each problem that you're looking at and trying to digest the deeper principles behind it. Maybe some of the ones I'm trying to talk through today, like, okay, I can say leverage symmetry, but what does that actually mean? What does it mean to look at a symmetry of a problem and turn that into something that's formulaically useful? You just have to see it a lot, and then be pensive when you do. Don't just be satisfied with the answer. See if you can understand why that answer came out. So in that way, this number 7, like it's the most frustrating, but it's the most real of all the problem-solving tips that there can be, which is that true problem-solving comes down to a kind of pattern recognition, and there's no two ways around it. You just have to do a lot of practice and expose yourself to a lot.